through that first grouping of 9 and 3, which I you know, it's the dumb things that you'll remember. You'll remember a lot of factors, but you remember this stuff. Which one? 18. Let's take a look at number 18. All right, number 18. Number 18, when we go through the whole process, first thing we got to do, if you recall, was that you would look for your zeros of the numerator. Zeros of the numerator means I have to factor my numerator. So take out the x, and I have 2 zeros. My zeros will be located at 0 and -1/2. Those are my x-intercepts. So my x-intercepts will be at 0 and -1/2. Okay? My vertical asymptotes will be located at the zeros of my denominator. Well, in this case, my denominator is x squared plus 1. So do I have any real zeros here? No, I don't, so it's fine. There's no vertical asymptotes. So then I go to my horizontal asymptote. When you go through the horizontal asymptotes, remember there were 3 things you had to look for. Your degree of the numerator was either larger, smaller, or equal to the degree in the denominator. In this case, they were equal, which meant that we treated just like we did the day before. Remember how we had linear over linear? We looked at coefficients. Well, here we have quadratic over quadratic, which means I look at coefficients. So I'm going to have a horizontal asymptote. What the hell is that? Is it going to do something? Is it not strong enough? Yeah. It's kind of moving. I swear it works.
It looks like a spider at Smush Flash.
We'll come back right to it.
It worked. Go get him.
It's tired.
My half day is ruined.
Just fix it and come back.
It's a little tired.
It's like you ever see a puppy just fall asleep and go. That's what it was. You wanted to go over and scratch. Oh, you're funny, baby. So we have that. We okay with that? Now on what day was that? Monday. No, I'm sorry, Tuesday. What day is today? So on Tuesday, that's all you had to do. Now, if you had that problem yesterday, you would then pick some points. Now, in this case, you've got intercepts. So you've got some intercept here between, you got your 2 zeros between here and here. So what I would want to do is pick some numbers, a couple numbers this way, and a couple numbers this way, and maybe use -1/4, so I can see if it's down or is it going up between them. See where I'm going with that? So I'm just going to pick points then. So I'm going to kind of blend this with what we did Tuesday into what you did yesterday so you can get the idea of more practice. Does that make sense? So if I choose some values here, if I use -3, -2, -1, well, let's start with -3. -3 squared times 2 plus -3 over -3 squared plus 1. Well, that's 9, 18, 15. 15 over 10. So that's 1.5. So here's here. If I use it at 2, I have 8, 6, 6 over, what is that, 3? No, that's not right. They get to be right asymptote. What's that? Okay. You wait, no, 6 was positive 3, so it's at 2. There's a pre-calc thing that happens that you can get discontinuity, where it's there and it's not there. Okay. And then going on. What happened at 1? You can put a little. The ones that you're really going to plot, they're gonna be clean. So I'm just kind of showing why you would pick points. So you have 2, 1 over 2. So it'll be at 1/2. So it's probably doing something like this. Maybe, I'm guessing. Did it look kind of like that if you graphed it with a calculator? Now, when we got to yesterday's, what do you want to look at from yesterday's? Not doing all of it. Select. Remember, guys, you guys have to learn to become a little bit more. Yeah. So when you get through this, when you start this one out, you have x-intercepts. You always go with your x-intercepts first. My x-intercepts here, guys, set the numerator equal to 0, solve for x. So you're going to get plus or minus, would be root 3, so be 2 root 3, oh sorry, so be root 6 over 2. Let me simplify that. So you get root 3 over root 2, which is root 6 over 2. Okay. Add 3 divided by 2, take the square root. So that gives you your asymptote, or sorry, your x-intercepts. Your vertical asymptotes are at -2. And then you have your horizontal. There's no horizontal. But what is there? Slant. There's a slant. There's a slant in this case because your degree of the numerator is 1 more than the degree of the denominator. Therefore, you have a slant. So you have to do long division. How do you turn an x into a 2x squared? Nice. Multiply by 2x. 2x squared. 4x. Subtract out. Multiply it now by a -4. And I really don't care about the rest of it because that gives me my equation of my slant asymptote. The remainder doesn't matter. Yep, the remainder doesn't matter when you're talking about your slant asymptote because just as soon as you get to the linear portion of it, that is the equation of the slant. Okay. So now you have enough here to kind of graph through. 0 denominator, yeah, always. Doesn't matter what type of function it is. So we had vertical asymptotes at -2. Plus or minus the square root of 6. So that's what? A little bit more than 2, but less than 3. So divided by 2, so it's around 1-ish. Plus or minus 1-ish. Something like that. Remember, one of the easiest things to find is going to be your y-intercept. In this case, what's my y-intercept? It's -3 over 2. So this is telling me that it's probably moving down and going back up, but I got to figure out what's going on the other side. Oh, and I got a slant at -4, so let's see here. Up 2 over 1. What's that? I'm putting in zeros for my x's. I'm getting the y-intercept. So your curve is probably doing this, which means there's a mirrored one way down below doing the other side. Okay. And that's how you place those things out with your asymptotes. Okay. 28, very, very similar. Well, actually, it's 28's easier because you don't have any vertical asymptotes. All you have to worry about here is you have no vertical asymptotes, but you have intercepts at plus or minus 2. You have intercepts at plus or minus 2. No vertical asymptote. Horizontal asymptote where? At 1. Very good. And where is your y-intercept? Negative 4/3. Remember, your y-intercept is always going to be at where x is equal to 0. So just by looking at that, bless you, just by looking at that, you can probably guess it's doing that plug the asymptote, dip down, and come back up and plug the asymptote. You can verify that by picking a couple of points on the outer edges. So I use -3 and +3. I should get the exact same answer, shouldn't I? Because there's no x constant there. So these are the style that you should be able to figure out pretty quick. What's 3 squared? 9. What's 9 minus 5? I'm sorry. 9 minus 4. 5. What's 3 squared? 9 plus 3? 12. So at 3, it's 5/12, which is just about halvesies, so it's here-ish. You're doing that. Good, 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 good. Told you it's not, shouldn't be tough. It's methodical. This is very, very methodical. There is a specific means to which you do every single problem. It never changes. Yay! Okay. What times what's 2 you add together to get 3? 2 and 1, right? Very good. So the way you said it is, yes, it's 2 and 1. So you have 2x squared plus 2x plus 1x plus 1 gives you 2x, x plus 1. So you have 2x plus 1 and x plus 1 for your numerator. What times what is 4? You add together to get -5. -4, -1. So just by factoring that right away, you now know where your x-intercepts are, because they'll be at the zeros of the numerator. And you also know where your vertical asymptotes are going to be, because they are the zeros of the denominator. So we start. Vertical asymptotes, 1 and 4. Zeros, -1/2, -1. Now, this is the case where we have to also look at our leading term coefficients because our degrees are the same. When our degrees are the same, we just look at the coefficients. We have a y equals for a horizontal asymptote, which is at 2. So now you've got 3 sections you have to look at. In here, and out there. It's just a matter of substituting in values. Hopefully you have learned that you can use when you use the calculator to type stuff in, just overwrite your data. Sometimes that's pretty quick too. Otherwise, tables work sometimes as well if you get clean numbers and so on from there. But that's what you're supposed to, that's how you set up the whole generic part. Plugging points is the easy part. Let's see, what's left that you had add forwards with? I'm not doing all of them. You can't just say all of them. That's a cop out. That's just easier not to roll it back. I did that once with my kids' Power Wheels. I hot-wired it to a giant motorcycle battery.
I'm trying to throw 4 of these in series.
I didn't put a fuse on it. That's a great story in case you guys ever need to learn something important. Yeah, when you hotwire Power Wheels for your children, if you guys ever decide to have children at some point in time. What I mean by hot wiring them, it's by putting a giant battery on a Power Wheels car. It's a great idea. So I took a regular 6-volt Power Wheel and I hot wired it to a motorcycle battery, which has a lot of cool cranking amp to it and stuff like that. So when you hit the gas, the Power Wheel would do this. It literally did wheelies, but I forgot to put the real important thing called a fuse. So I forgot to put a fuse on it, and my kid drove away on it. Next thing you know, you see smoke and flame coming out of it. Get out of it, put the fire out. But then we fixed it, and it used to have a gas pedal to it, but all the wiring to it melted so badly, so we put it to an electrical switch. So we mounted, so next to the steering wheel, you had an electrical switch to turn it on and turn it off. So my kids would get in it, and with 2 kids in it, my kids are large, and I mean like they're like beasts, but my children were born rather big, and I'm tall, they're tall. So the 2 kids are in this Power Wheel, a Jeep thing, and with the 2 of them in the front of the Jeep would still do wheelies as they go around the neighborhood. We had to tell them to wear helmets while they were riding in a Power Wheel because it would run into stuff. They went around a corner once so fast on the sidewalk they lost traction because of the plastic wheels, ran into the fire hydrant, and one kid went over the hood into the grass. He's crying, "Oh!" I'm like, "You okay?" He's like, "Fine, let me get back in." Just back in and take off down the street. So Ohm's law is important. Fuses are important. Helmets are important. Ladies and gentlemen, get the rest of these. Do the odds for this tomorrow. We'll finish this out.
But that one's
Always wear a helmet. I'm not kidding about any of that. That's all that stuff. Remember I told you 80% is fake, 20% is true? Or sorry, 20% is fake, 80% is true? That's the 80%. That's all true stories. My children went head over heels over the hood of a Jeep because my child went. It's fun.
It's so fun because we just get robot parts. So my dad and I started building a 3D printer and we never finished.
He's got one next door now.
I know, and we're trying to figure out how to make like actual Star Wars weapons and stuff.
Oh, that's cool.
I'm really excited. Yeah.
All right, if you're going tonight, you can't tell me anything.
I'm not going tonight.
I don't want to be able to go until. Oh yeah, guys. This is a spoiler-free room, okay? Because I'm not gonna be able to go until probably next week. So. Yeah, I'm sure. So yeah, flipping you off my break. Hey, don't say anything, please. Otherwise, your final grade will be fairly sorely affected.
Yeah.